this video, we're going to look at what we consider function notation. We've already talked about what a function is. It passes the vertical line test. X's cannot be repeated. Y value has to be raised to the first power. With function notation, we need to be able to, what we consider, name our functions. Because let's say that I have this graph on here, and then I have another graph on here that looks something like this. Well, both of these are functions, but I don't know which one I'm talking about, especially if they're both drawn in the same color, they're black and white. If I just say, look at the function, you wouldn't know which one of these I was talking about. So what we do is we have function notation, and that function notation is just a way of naming things. It looks like f of x, or it could be g of x, or it could be h of x, and I'm not sure why. So function notation could be any of these. It could even be s of t. What these are talking about, these right here, the f, the g, the h, the s, are just the names. The variable inside is the variable that's going to be inside the equation, such as x plus 4. Or maybe we have 3x squared minus 2. Or we have 7x plus 3x squared minus 8. Here, we would have something that looks like 3t squared plus 2. So it's just looking at whatever this variable is in here. The function notation, as we look at it, this is replacing our y value. So this entire thing is the same thing as our y. So if I look at a function, if I have y is equal to 4x squared plus 2, I can write that in function notation, f of x equals 4x squared plus 2. These two things mean the exact same thing. Another reason why we look at function notation is because maybe it's going to help us with determining some values. So if I say I want f of -3, this does not say I'm multiplying my f by -3. What this is saying is I'm replacing my x with a -3. So if I replace my x here with a -3, I'm also going to replace it over here with a -3. And so I'm going to have 4 times -3 squared plus 2. And I'm going to solve that. So 4 times -3 squared is +9 plus 2. 4 times 9 gives me 36 plus 2. So that gives me 38. So f of -3 is 38. This actually gives me an x and a y. This is my x, this is my y. So if I were to write it in an ordered pair, it would look like this. Now I can put a lot of things inside that function notation. Let's look at if I have h of x is equal to a 2x squared minus 3x plus 1. And let's say that I want to find h of the square root of 2. Okay, that just means I'm replacing the square root of 2. I'm putting it in place of my x. So I'm going to have 2 times the square root of 2 squared minus 3 times the square root of 2 plus 1. square root of 2 squared. Remember, the square root and the square cancel out, so that gives me 2 times 2. Now, in this term, nothing can really happen. So I just get minus 3 square root of 2. That's all that can happen in that one. And then I get the plus 1. And so I get 2 times 2, which is 4, minus 3 square root of 2 plus 1. I can combine the 4 and the 1, so I get 5 minus 3 square root of 2, and that's an awful looking 2. Let me try that again. And so h of square root of 2 is this ugly looking mess, but that's as far as I can break it down. Now, I could put it in my calculator and get a decimal place, yes, but most of the time we want these exact values, and we've talked about those before. Now, using that same h of x was 2x squared minus 3x plus 1, I want to find h of 3 plus z. We have to be very careful with this one. So I have 2, and in place of my x, I'm going to put that 3 plus z, and then I'm going to come back over here, have my square minus 3, and again I'm going to put 3 plus z, and then my plus 1. What most students want to do is just distribute this square and give me a 9 plus z squared. That is not correct. Think about what a square actually means. It means multiply this thing by itself twice. So if it is easier for you, write down that set of parentheses twice and then do the multiplication. So whenever you go to actually multiply it, and I'm going to go ahead and finish out the parentheses here first. You may use FOIL, you may use what's considered distributive property. I'm going to take 3 times 3, which is 9, 3 times z, which is a positive 3z, z times 3, which is another positive 3z, and z times z, which is a z squared. Now notice it still has that 2 sitting out front, so I've still got to put this multiplied by 2, and then I'm going to go ahead and multiply the negative 3. Make sure you take this sign with you, and so I get negative 9 minus a 3z, and then I still have that plus 1 out there. So I'm going to distribute my 2 in here. So 2 times 9 is 18, 2 times 3z is 6z, 2 times 3z is another 6z, 2 times z squared is a 2z squared, minus 9 minus 3z plus 1. And then I'm going to start combining like terms. When I combine like terms, I'm always going to start with the variable with the largest exponent. So that's my 2z squared. I don't have any other z squareds, so I'm going to leave it, 2z squared. Then I'm going to go to my z's. I have a 6z plus a 6z, which would give me 12z, minus 3z, which would give me what? So that should give me a 6z plus 6z is 12z minus 3z would be a plus 9z. And then I'm going to go to my constants. So 18 minus 9 gives me 9, plus 1 would give me a plus 10. So one of your biggest things is be careful when you have something like this. You cannot just distribute that square. That's not possible. Make sure that you actually do that FOIL or distributing. Now I want you to try some with function notation and let me know if you have any questions.